Section 2.6, Ratio and Proportions. A ratio is a comparison of two numbers by division. The ratio of x to y can be expressed in the following ways. X to y, x colon y, or in algebra we write it x over y. An equation stating that two ratios are equal is called a proportion. This is a proportion where this ratio is equal to this ratio. To determine whether each pair of ratios are equivalent, put them equal to each other. 2/3 is equal to 16 over 24. And then we would cross multiply. When you cross multiply, if the left side equals the right side, then they are equal. So 3 times 16 is 48, and 22 times 24 is also 48. So they are equal. You could also see that you could reduce 16 over 24 and to get 2/3 as well. That's another way of looking at it. Example B, put 6 over 10 is equal to 2 over 5. Cross multiply. 2 times 10 is 20. Is equal to 6 times 5 is 30. 20 does not equal 30, so this is not an equivalent ratio. Use cross products to determine whether each pair of ratios forms a proportion. So we are going to do the cross product. 2 over 3.5 is equal to 8 over 14. Now, if you have a calculator, it certainly is easier, but if you don't have a calculator, then you'll have to go to the side and multiply. 2 times 14 is 28, 28. And 3.5 times 8 is also 28. So it checks, it is a proportion. Part B, 0.3 over 1.5 is equal to 0.5 over 2.0, which is just 2. 0.3 times 2 is 0.6, and 1.5 times 0.5 is 0.75, and that is not equal, so it is not a proportion. Example 3, solve each proportion if necessary, round to the nearest hundredths. Okay, so again we're going to cross multiply. It really does not matter which one you do first. I like the variable on the left side, so I am going to cross multiply where the variable is on the left side. So that's 8 times that whole numerator, which is, you have to multiply 8 times that whole numerator. So when you go to multiply, you have to put that whole numerator in a fraction. Is equal to 5 times 3 is 15. Then we do the distributive property. 8x is equal to 30 plus 32 is equal to 15. Subtract 32 on both sides. (32) minus 15 is 18. 17. Divide each side by 8. And x is equal to 17/8. Example 4a. In the past 2 years, a retailer has opened 232 stores. If the rate of growth remains constant, how many stores will the retailer open the next 3 years? Okay, we can set this up in a proportion. Your little formula for your ratio are going to be the retail stores over the number of years. And it is very helpful to always write your little formula of what your proportion is going to be. That way you'll make sure that you put the number of stores up top and the number of years in the bottom. So, in the last 2 years, or you could have done the number of years up top and the stores on number of stores in the bottom. It really does not matter. The number of stores is 232. And the number of years is 2. Well, the question is, how many stores will the retailer open in 3 years? So where does the 3 years go? In the bottom. What do we put up here for the number of stores? X. So now we're going to cross multiply to solve a proportion. 2 times x is 2x. 2 times 3 is 696. Divide by 2. And x is 348. And what is that? That is the number of stores that will be open in 3 years. Now again, if you would have chosen to do number of years over the number of stores, you would have still gotten the same thing. It would have been 2 over 232 is equal to 3 over x. And you still get the same thing. It does not matter. What matters is that you do the formula so that you're consistent. Example B, the gear on a bicycle is 8 to 5. This means that for every 8 turns of the pedal, the wheel turns 5 times. Suppose the bicycle wheel turns about 2,435 times during a trip. How many times would you have to crank the pedals during the trip? Okay, so we're going to set this up again in another proportion. Our formula is going to be the number of turns on the pedal is the number of wheel turns, or something to that nature. So for every 8 turns of the pedal, the wheel turns 5 times. So when the bicycle wheel turns 2,435 times during the trip, how many times would you have to crank the pedals? So where does the 2,435 go? It goes in the bottom because that's the wheel turns. So again, if you don't have this formula, you're not going to know where to put the 2435 on the top or the bottom. Cross multiply. 5 times x is 5x is equal. We're going to go to the side. I am going to use a calculator to multiply that. And I get 19,480. And then divide both sides by 5. And you get 3,896. And what is that? That is the number of turns on the pedal. A scale is used when making a model of something that is too large or too small to be convenient at the actual size. The scale compares the model to the actual size of the object using a proportion. The scale of a map of the Great Smoky Mountains National Park is 3 inches is equal to 10 miles. The length of the Ramsey Cascades Trail is about 1 1/8 inches on the map. What is the actual length of the trail? So we have the inches. My little formula is going to be inches over miles. And it says the scale on a map says 3 inches is equal to 10 miles. So that's 3 over 10. I don't put the measurements in because the measurements are in my formula. is equal to, what is the length of the trail? The length of the trail is 1.5 inches on the map. So what is the actual length of the trail? So where am I going to put the 1 1/8? I'm going to put it up top. Now I have to multiply 3 times x is 3x. Now I have to multiply 10 times 1 1/8. When you multiply fractions, you have to turn it into an improper. That's 9/8. So if you want to go to the side and multiply 10 over 1 times 9 over 8, I am going to cross reduce. 2 goes in 8 4 times. 2 goes into 10 5 times. 5 times 9 is 45 over 4. Now, to solve for x, I am not going to divide both sides by 3 because that is a fraction. And if I divided by 3, it would look like this. Then I'll have no idea what to do. So you don't divide by 3. We are going to multiply by the reciprocal. And the reciprocal of 3 is 1/3. So multiply both sides by 1/3. Again, cross reduce. 3 goes into 45 15 times. So 15 times 1 is 15 over 4. Now, because we're dealing with measurement, we do not leave it in an improper fraction. We have to turn that into a mixed number. And 4 goes into 15 3 times with 3 left over. So the trail, the actual length of the trail is 3 3/4 miles. Example 5b. On model airplane, the scale is 5 centimeters is equal to 2 meters. If the wingspan of the scale model is 28.5 centimeters, what is the actual wingspan? So we have the scale is centimeters, and the actual model is meters. So the scale is 5 centimeters over the actual 2 meters. If the wingspan of the scale model is 28.5 centimeters, where does that go? It goes up top. What is the actual wingspan? We don't know. So I'm going to multiply 5 times x is 5x is equal to 28.5 times 2 is 57. Divide both sides by 5. And you get x is equal to 11.4 meters. That is the actual wingspan, is 11.4 meters. There is your homework.